Okay, 2.5 zeros of a polynomial. This is our last section. Our test is next week.
No.
Our test is like Tuesday or Wednesday.
What did we go over again? Is it over like synthetic and all that?
Yeah. Okay. We'll have a review. So, well, you don't have my school on Monday, so it's like Wednesday. Okay.
I vote Thursday.
Well, you don't get a vote, so that's okay. You're not old enough yet.
The school board say that we shouldn't have a test next week.
Yeah, no. Okay, so you don't need to write this all down. You just need to know it. Okay. Well, some of it you need to write down, but not all of it. So be picky. You know that an nth degree polynomial can have at most nth real zeros, yes?
Yeah.
But there are exactly n zeros. What did I leave out? Real. We know that they're imaginary numbers, yes?
Uh-huh.
So there is, on a fifth degree polynomial, there are 5 zeros. Did I say 5 real zeros? No. There are 5 zeros. That's what this says. It's called the fundamental theorem of algebra. And in the complex number system, every nth degree polynomial function has precisely n zeros. This is what you need to write down. What is bolded and what is underlined. The fundamental theorem of algebra says in the complex number system, every nth degree polynomial function has precisely n zeros. And what word is missing there? Real. And I'm just going to talk while you write. The fundamental theorem of algebra tells us that the zeros exist. Does it tell us how to get them? No. Does it tell us they're real? No. It just tells you that they are there. So when you look and you see a third degree polynomial, when you solve it, you should get how many solutions? 3. When you look at a fourth degree, how many solutions should you get? 4. Can you get 6 on a fourth degree? No. Are some of them going to be double zeros?
Yeah.
Yes, could be. Oh, while you guys are writing that, does anybody want... No, I think I already got rid of them. Never mind.
What?
You don't get the option. Those papers when you used your graphing calculator and found zeros and asymptotes and all that kind of fun stuff. It's fine. Okay, you guys ready?
No.
Leave your phone away. I can tell you what time it is. Not time for class to be over.
Oh, get exposed.
I don't want class to be over. I have a test next week.
I had one.
High quality joke.
You ready now? You're just writing one sentence.
Yeah, I know.
Okay.
Hey,
Okay.
there's like 2 commas though.
Oh yeah, that's rough. Okay. So find all the zeros. Well, how are you gonna? What kind of equation is the first one? Linear. Thank you. Okay. How many solutions are we gonna have? 1. Now with the linear, do you have to have one real solution?
Yes.
What about horizontal line? Does it have one real solution? No, because it never touches the x-axis, does it? Okay, so but every other linear equation, does it have one real solution? Yes. Okay, so how would we find this one? Equal it to 0, just like any other day, and x equals what? 2. So a solution, x-intercept, and what was the other word? 0. Thank you. They all mean the same thing, right? This is where this graph crosses the x-axis, correct?
Yeah.
Okay. X cubed plus 4x. How many solutions are we going to find? 3. How are we going to find those 3?
Factor out an x.
Factor an x.
X squared plus 4, difference of squares.
Nope, not a difference of squares.
They're imaginary.
They are imaginary because it's the sum of squares, yes?
Yeah.
Okay, and if we forget that we can factor that, we just set both of them equal to what? 0. And I get x equals 0. And I get x squared equals negative 4. Then what? Square root. And my answer is
17.
Plus or minus.
Plus or minus, thank you very much.
2i.
2i. So, how many solutions do I have?
2. 3.
3.
Because plus and minus.
Plus and minus. Okay, I have 3 solutions, but how many real solutions? 1. So these are solutions. But if I want real solutions, I have 1. So make sure you read your directions. You will always find all 3, but your final answer, if it says real solutions, you need to circle the real part. Got it? Or write real next to it. Because on your test, I will ask you for the solutions. So I want all of them, yes? And I will ask you for the real solutions. Do I want all of them?
No.
Nope, I just want the
Real.
real ones.
What if I give you all?
Then you'll get points off not knowing that there's a difference. Okay. So, x squared minus 6x plus 9. How many solutions am I going to have? 2. How am I going to find them? Factor. So do it. So did you get 2?
No.
Yes, you did.
Well, yeah.
No, I got 3.
This is a what? Double solution, a double zero, yes? And so what's the graph going to do there? Bounce. So that must be its vertex, huh? On a parabola, the only point that it can bounce is its vertex, correct? Yep. So its vertex is at 3. So if I could already sketch it, couldn't I?
No.
And the y-intercept is 9.
Yup.
Look at that. That's amazing. Better than yours. You didn't even do it. Okay, next one. How many am I going to have? 4. Do it.
That's where you're wrong.
All right, yep, set it equal to 0. All of them, basically, you have to set them equal to what? 0. You may have to move it back, but setting equal to 0 is a good first shot.
Do you want to square it? Can we take the 4th root of it?
Well, you guys got some options. Do I have perfect squares?
No.
Do I have the difference of perfect squares?
No.
Yes. So could I factor it? Could I? Okay. So it would be x squared minus 1 and x squared plus 1. Yes?
Okay, yeah.
Okay. And then actually I could factor both of those again. I could have had x minus 1 and x plus 1. How would I factor the sum? What has to be there to get a positive? Is it going to be a real solution on this x squared? It's going to be an I, isn't it? So it'd be minus I and then what?
Plus I.
Plus I.
Wait, wait.
To factor this, since it's the sum, you have to have an I in there because that I squared is going to make the negative a positive.
Yeah.
If I FOIL this out right here, I have x squared minus ix plus ix minus I squared. And so I have x squared, and this becomes a negative 1. And a negative is a positive. So if I had x squared plus 4, that would be x plus 2 what? I and x what?
Minus 2i.
Minus 2i.
Oh.
Okay? So now what are my solutions here now? X equals plus or minus 1 and plus or minus I. Now, my other option is, did you guys just set it equal to 0 and add over 1? Yes?
What at the end to do?
Okay, so you added over 1, yes? And then you took the what root? The 4th root. Yes?
Yes.
Okay, so you got x equaled plus or minus 1. But what don't you have?
The I.
The i's. Okay, I got the real solutions, yes?
Mm-hmm.
But did I get the negative ones?
No.
No. We're good? Okay, the rational zeros test. The possible rational zeros. That's what you need right here. Possible. Did I say they were?
No.
No. Rational means, what's a rational number?
Fraction.
A fraction. Anything that can be written as a fraction or a terminating decimal, yes?
Yeah.
Yes? Okay, so I didn't say anything about imaginary or anything like that, right?
No.
So it's the possible rational zeros. It's the factors of the constant term. If we've written in order, that's the last term, yes? With no variable. Divided by the factors of the leading coefficient. So you have to have this in order before you do it.
Mm-hmm.
Yes?
Yes.
Anybody remember listing these out last year?
No.
It was so much fun.
No.
Okay, so possible rational zeros test. This is how you get an 8th degree polynomial and start working on it to be able to get it, because we don't know how to do 8th degree and factor it, do we? Unless it was 8, if x to the 8th minus 1, we could factor that one. But if it had x to the 8th, x to the 7th, 8 to the 6th, 5, 4, 3, 2, 1, we wouldn't know how to do that, would we?
No.
So what we do, and I don't know how to do that either, what we do is use this possible rational zeros test to do synthetic division to get a 0, and then every time I do synthetic division, what happens to the degree of the polynomial?
It decreases.
It decreases by 1. So if I can decrease it to a cubic, sometimes I can do it, because we have rules for certain cubics. But if I can reduce it to a quadratic, do I always have something that will work?
Yes.
What is those two things?
Quadratic formula or just factor.
Right, just factoring or quadratic formula. So that is the point of this. Everyone got it down? So you will be using this because you're looking for the possible rational zeros. Okay, so find the rational zeros. So first of all, we need to put in order. Is it in order? Yes? We need to get the possible rational zeros. So possible, so the PRZs. Okay? So PRZs, because I don't know how to factor a 4th degree. Do you know how to factor a 4th degree? No. Because like if 3rd degree, we could maybe do grouping, couldn't we? Because there's 4 terms. But this one we can't. So we need, it was the factors of what? The constant over the what? Factors of the leading coefficient. Okay, so the factors of 6 are
3 and 2. Negative 3 and 2. 1, 2,
1, 2, and 3. And all of them are
and 1.
plus and minus.
Yes.
Oh, I remember this.
Okay, now I'm going to tell you right now your book lists them individually, and it's horrible. And especially if like the leading coefficient was 6 also, they list them all. I don't care. Just do the ones over the other. You can make the fractions on your own, can't you?
Yeah.
Okay, so the factors of the constant divided by the factors of the what? Leading coefficient. What is the leading coefficient?
4.
No. 1. Coefficient is the number in front of the variable, yes? So that's nice. So all of these are whole numbers, aren't they? Okay. So now what we do is we set up our synthetic division. Any holes we need to do? No.
Oh,
And then you pick. You got plus or minus 1, 2, 3, or 6. You got 4 options. Where do you guys want to go?
6.
6.
1.
Why would you pick 6?
Because I
Okay.
want to do 6.
Why would 6 probably not be a good selection here?
Well, because
Because
the
you get
last
big
term
numbers.
is only 6.
The last term is only 6, and you probably end up with something really bad, right? I tend to stay away from 1 and 6. I mean,
Pick two.
So let's go to 3.
Let's go two. Or
3, 2. It doesn't matter. I mean, we can honestly pick 6 if we want. What do you guys want to do?
Two.
2?
Negative 2.
6.
Okay. The goal is to get a what for the remainder?
0.
0, because we're looking for what?
Zero.
Zeros. So we need a 0 for the remainder. So you do it, I'll do it. Hopefully I won't mess up because I'm not trying to talk about it.
Yep.
It worked?
Yeah, I got 0.
Okay. If it didn't work, stop and erase and go back. Don't finish it out. Because if you know it's not going to work, why would you finish it? Okay, so you got 0? Okay. So I started with a 4th degree. Now I'm at a what? Third degree. At 3rd degree, we maybe could group, or could we keep going?
Keep going.
We could keep going. Okay, so now the same thing applies. Constant over leading coefficient. So what factor can I get rid of now?
6.
The 6. Because it's not, correct? The constant's 3? Because this would be 3, 2, 1 constant.
Yep.
Okay, so what do you want to try?
1.
1? Nope.
Nope.
Okay, so now let's just make it -1. And sometimes you can just reuse your work.
Yeah.
-1 worked, correct? So I'm good there. So now I was started at 4, 3, what do I get now? 2. So I can factor this now, right? I do not have to keep continuing. This is called repeated synthetic division. You notice I did not start all the way over, did I?
Yeah.
Because if I did, it's not doing me any good to decrease those powers. So now I have x squared plus 3, don't I?
Yes.
So I need all the rational zeros. So I would do what to solve this?
Subtract it through.
Okay, so x squared -3 square root. And I get x equals plus or minus the square root of 3 what? I. And -1 and 2. So these are all the zeros.
So the thing that you divide,
Zeros does not start with that. Say that again.
the thing that you divide by is the 0.
Yes, they are zeros because they came out to be zeros.
Okay.
Yes? Okay, now this could have come out to be zeros also, which it did, but are they real? No. So these are all the zeros. So what are the rational zeros?
-1 and 2. Right?
Mm-hmm. Okay, so, ooh, I got really close to the no man's land. So when you're doing this, I would encourage you to write all next to here. And then write rational or real, depending on what the question's asking you for, next to the correct answer. That way your brain can start distinguishing between all and rational. Another one?
Hold on, before you continue.
Yes, sir.
Where'd you get the 1, 2, 3, and 6 from?
1, 2, 3. Factors of 6.
Constant term.
Factors of your constant term divided by the factors of the leading coefficient. So the factors of 6 are 1, 2, 3, and 6.
Was the last number always the constant?
Oh, the lost.
Well, it better be. You better write it in order before you start, correct? Okay. Now, if there's a variable there, then you could factor out a variable, and then that would be 0, and you could work with the rest of it. Other questions? Did that get you? You good?
Yeah.
Okay. Find all the rational zeros again. So the PRZs,
1, 3.
so PRZs equals the factors of 3 over the factors of 2. Now, I trust that you all can see that 3 halves is a possible answer, yes? Now, in the textbook, when it asks you to list all the rational zeros, possible rational, it says 1, 2, 3, 3 halves, 1 half. You know those are there. This is all I want for that, okay? So you do not have to follow what the textbook is saying. Okay, so I'm assuming you guys don't want to start with 3 halves, do you? No. Well, first of all, was this in order? We probably should have checked that out first. Was it in order?
Yes.
Yes. Always has to be in order, right? Any zeros I have to contend with?
No.
Nope. So let's start with 3 halves, right?
Yes.
Okay, so this one we only have to do 1 time in order to get down to a quadratic, don't we?
Yeah.
Okay, what do you want to start with?
Two.
Start with one.
And
Well, no.
one.
3.
Three.
3.
Yeah, 3.
Okay,
3.
Thank you.
I'm stopping.
Yeah.
Alright, too big.
Why did I stop?
Cause it's too big.
Because I'm going to get 27 and then I'm going to get,
-8. and
yeah, it's going to be too big. So let's just switch this positive to a what now?
Negative.
Negative.
Heavens, you're falling, you know?
That work?
Yeah.
Yes. So 3 was our rational zero there. So now can I just factor?
Yep.
Okay, what's my equation?
2x squared minus 3x plus 1.
How did you know that?
Because it's 1 degree lower.
It's 1 degree lower. So I need factors of 3 that add to 3.
Negative.
Oh, factors of 2 that add to 3. Sorry, can't multiply.
1 and 2.
1 and 2. Woo woo.
Would it be -1 and negative?
Yeah.
I mean, I just guessed.
Okay, so I need to get, well, this is just going to be 1 and 1, right? So all my zeros are x equals what? 1/2, 1. Oh, I put my -3 behind. Okay. So what are all my rational zeros? The same. So now I can write them in order, right?
Would it be a -1/2?
No.
Never mind.
And you could just put all and then you could put rational in front of it, couldn't you?
Yeah.
But I had to write mine in order. Brad, better this time? Any questions? I don't know. I think there's probably another example. Are you guys good?
I won't be here tomorrow.
I think we're good. I don't think we need another example.
Damn.
Okay. Okay. I don't. Why did I put this one here?
Because it's a negative leading coefficient.
There's a
That
lot
doesn't matter.
Wait,
There's
a lot of.
there's a lot of them. Yes.
Yes.
Okay. So what are your PRZs?
1, 2, 3, 4, 6, and 12.
We don't have to do them all.
But we're doing them all.
No, I'm saying we don't have to do the whole problem.
No, we're good.
So we got 1, 2, 3, 4, 6. Well, you guys said them faster than I am. And 12.
That was the kid that doesn't take notes, though.
Okay? It doesn't matter. It's just
And the factors of 10.
1, 2, 5, and 2.
Factors are your problem, is what you just said, Brad.
Yes.
5.
But I can't factor, that's my problem.
Well, I hope you could factor 10. Hey,
I factor 1.
so do I have a lot of choices here?
Yeah.
You actually
Yeah.
do.
I do have a lot. How about 3/5? Let's start with -3/5.
Yes. I agree. Actually, start with.
Okay,
Let's start with.
do you guys need to do this one?
Yes.
Yes? Okay.
Actually, yes. So 10, 15.
What?
16, 12.
Probably not going to start with 1, huh?
I say 3.
3. I think.
2.
3?
2.
2. Do 2.
2.
Well,
Fine.
ooh.
2.
Aw, I said 3.
Oh, you guys got lucky.
Wow.
Legendary.
Okay, could you pick really badly here?
Yeah.
Yeah, because my only choice is there's only 3,
Oh, I
right?
should've said 12.
So I could have gone. It could have gone really bad. We actually did pretty good. I was hoping you'd pick wrong.
Nope, we're
Put 3 down.
Okay, x squared, x, yes?
Yes. We're just at
So factors of 60
negative 60.
that have a difference of 5. Oh, wait a second. I should not do it this way. I should do what with my negative?
Oh, factor it out.
30 and 2.
I was gonna say 12 and 5.
30 and 2.
Okay,
Yeah.
so now let's do this. 30 and 2, yeah, that works. Okay, so we started with 6 and 10, yes?
Yeah.
So 6 and 10, that didn't work. Well, 6 is 2 times 3, and 10 is 2 times 5. So rearrange those.
Huh?
Like
2 times 2 times 3 times 5.
2 times 2, that's all 60. Okay,
Always have.
2 times 2, 4. So 4, that'd be 12, and that'd be 7, wouldn't it? Let's see. 15 and 4, that wouldn't be
20 and 3.
20 and 3. Yeah, no. I'm tired of looking. What do I use?
Quadratic.
Quadratic formula. Okay, I probably would have been tired of looking 2 seconds into this one and just jumped to quadratic formula, because even if it works, then it's going to come out nice and neat, right?
Yeah.
I did. One time in my teaching career, I had a student that never factored. She went to quadratic formula every single time. She goes, I don't want to look. Like, okay. She did it really quick. Okay, so I have what? Negative 5 plus or minus.
You get negative 1.06394138.
Okay, so it's a good choice that we're going to.
Wait, are you going on from the where you factored out?
Yes,
Okay.
going off, factored out the negative. Minus 4, so plus. So 24 times 10 would be 240, right?
Yeah.
Okay,
4 times 2.
over 20.
Yep.
So I get the square root of 265.
Square root of 265.
Oh, well, that's nice. 265 is prime. Not prime, but no perfect squares. Because 265, I know 5 goes in there, yes?
Yeah.
So 5 goes into 26 5 times, carry 1 and 3. So I got 5 and 53. I don't have to look anymore, do I?
No, you do
Anything times itself get 53?
Yeah.
Or times,
1.
no, but time 1 doesn't count. Okay, so my answer is negative 5 plus or minus the square root of 265 over 20. And what? 2?
Yeah.
And are all these real?
Yeah.
Yep, they're all of them. But they're all real. Are they all rational? No, because what? Square root of 265 is not a rational number, is it? Nope.
No.
So the only rational one is what? Is 2. But look back at the directions. What was I supposed to find? All real. So my answer here would be what? All of them. But on the last slides where I asked for rational, it would only be what?
2.
2. So do I have to kind of know what?
You
You
Right here. Okay. So now this is just to look at the directions, please. Please just look at the directions. Okay, this is exercise 33 through 36. Okay, so these are the directions. List all the possible zeros of f. Did we do that?
Yes.
Yes. Okay, sketch a graph of f so that some of the possible zeros are in there. Okay. Seriously, I need to read right. Sketch a graph of f so that some of the possible zeros in part A can be disregarded, and then C, determine all the real zeros. Okay, guys, this is all I want you to do for part B. I'll show you, okay? Pretty much do what we've done except for part B. Okay, so part A says PRZs, right? So PRZs are what? 16 1, 2.
8, 16.
Over 1. That's nice, right? Okay,
1 and 3.
this is a third degree, yes?
Miss make 1 and 3.
1 and 3. Oh,
Yeah.
sorry.
Listen to Ethan.
Sorry. Okay, so this is a third degree that is negative. Do you know what a third degree negative function looks like?
Yes.
Yes. I could tell you that this graph has a y-intercept at 16, can't you?
I also could.
Okay, so here's 16. It has to go through this point, right here. Has to go through this point. Let me even get a different color so it might help. Has to go through this point. It has to end down and start what? Up. So that means it had to go here, here, and here, yes?
Yeah.
Okay, I just sketched it. All I know definitely it has that y-intercept, and I know definitely that it started up and ended down. Correct? That's all. That's all B is. Don't stress over it. If you want to see how accurate you are, you can look on your calculator. It doesn't matter. Next is determine all the zeros. So what do I need to do?
Determine all the zeros.
Determine all the zeros.
Rational zeros.
So I got what? -3. And guys, I haven't been pointing it out, but before you do any problem, you have to make sure it's written in order. Yes?
Yeah.
And do I have any gaps? No. Where do you want to start?
4. You were all
4?
wrong.
How do you guys keep guessing?
Did they guess right again?
I don't know, but it looks like it crosses through 4.
Oh,
Yeah, we guessed right.
we did?
Yep.
Well,
you just did your math wrong right
Yeah, you did your math.
It comes out
Yeah,
with
you took
16 at
4
the end.
times 8 and got 16.
Oh, yes, that would be incorrect.
4 and 8 is 32.
That was the one thing I didn't check.
-4, -4 and 4 is -16.
Okay. Now, you guys are starting in the middle, which makes more sense than starting on the ends, right? Okay, so we did down to a squared, yes? So x squared plus 8x minus 4. So factor out a negative. So I get factors of 12 that add to 8.
6 and 2. Negative 2.
6 and 2.
-6 and -2.
Okay, so 3 is prime, so my only choices are 3, right? And I've got to get 6, so this better be a 2. And the other factor of 4 is what? 2, and they're both negative?
Yeah.
So I set them equal to 0. So x equals 2/3, 2 and 4. So is our graph right?
No.
No, because if I moved it this way, it would be right, wouldn't it? These two are wrong because I need to move it, and that's all they want you to see. So don't get lost in those instructions. It's not asking you to do anything else except make a prediction of the graph. If you want to wait till you do this to make a picture of your graph, I'm all for that too. Get what I'm saying? Can I graph from here? So I have to go through 16, right? And then
You actually started
actually I probably should change my color. So I go through 16, and I probably should write 16 on there, and I will. 2/3, 2, 4. As long as I write a 16, it's all good. Yes? And so it has to come from here, go through that one, up through this one, and down through this one. We don't know this relative max or relative minimum. We'll say that for calculus. But can we get everything else?
Yeah.
Yes.
Yes, we can.
It's the whole point of doing what we're doing. I honestly, if it was me, making just a prediction would drive me nuts. I would do B after C. And I would encourage you guys to do the same. Okay, conjugate pairs. I don't know if we need to do conjugate pairs today. We'll do this slide just in case you get there, but we won't do anything else with it. We'll just do this slide, okay? So it says the pair of complex zeros, A plus BI and A plus minus BI, are conjugates, yes? Okay? If one conjugate pair is a zero, then guess what? The other is. Okay, we went over this before and we forget it, so we have to keep reminding ourselves of this. So, this result is true only if the polynomial function has real coefficients. F of x equals x squared plus 1, but not if the function is given as x minus I. X squared plus 1, are these all real numbers given to you? Yes. Is this function all real numbers? G of x? No. Now, if they told you the 0 was x minus I, you'd be good, because that's not the function, is it? So, conjugate pairs always exist if you started with what? All real numbers. So, if I say x equaled negative 2i, it also has to equal what? Positive 2i. Oops. So it would be both positive and negative 2i. Making sense what I'm saying?
Yes.
So if I tell you one factor is x equals 3i, 1, 0, yes?
It'll be plus or minus.
Plus and minus 3i. So the factors would be x plus 3i and x minus 3i. And the equation, when I FOIL that all out, would be x squared minus 9i squared. So x squared plus 9. Yes? Okay, so did I start with all real numbers? Yes. See how that works? Okay, so I do not think you have to use that fact today. We will finish notes tomorrow and go over questions. If you get to things where you have to use them and you don't know how, what do?
Wait.
You can wait. You can look in the book, whatever, but that's